Problem number 74, page 691, acid-base chemistry. An acid, HX, is 25% dissociated in water. If the equilibrium concentration of HX is 0.30 molar, calculate the Ka value for HX. Since HX is 25% dissociated, we know it's a weak acid. And weak acid is going to achieve equilibrium with its ionic components. So we're going to need to set up an icebox to help us determine the Ka value for HX. I've set up the icebox table and I've written in all the information that the problem tells us. We know that 0.30 molar solution of HX is at equilibrium. We can determine the change of concentration from the stoichiometric coefficients in the balanced chemical equation, and we know initially there was 0 concentration of H plus and 0 concentration of X minus. If we can figure out what X is, we can then set up an Ka expression to solve for Ka. To determine X here, we're going to have to figure out the initial concentration of HX. The problem tells us 25% of the original HX dissociates, meaning it breaks up. If 25% of HX dissociates, that means 75% is remaining at equilibrium. So we're told 25% of HX dissociates. We know that the equilibrium concentration of HX is 0.30 molar. If 25% dissociated, 75% is remaining at equilibrium. Setting up an equation, part over whole. The part that remains at equilibrium is 0.30. The whole amount would be the initial amount of HX we started with, and that's equal to 0.75 or 75%. Solving for HX naught, meaning the initial concentration, the initial concentration of HX has to be 0.4. Now, going back to our icebox, I've substituted in the initial concentration of HX that we just determined to be 0.4. Now we can solve for X. The initial concentration and change concentration combined gives us the equilibrium concentration, so 0.4 minus X equals 0.3, meaning X is equal to 0.10. Substituting X into these two concentrations, we now know the concentrations of each of the 3 chemical species in equilibrium here. Writing a Ka expression for this chemical reaction, substituting in the equilibrium concentrations, you can then calculate for Ka. Substituting in and calculating, you should be able to determine that the Ka for the weak acid HX is 0.033. Any questions?